Okay, problem number 5. The model below represents the equation 3x plus 2 equals 8. What is the first step in finding the value of x? First, let's make sure we agree with this equation. 3x plus 2, on this side I have 3 cups. They each represent x. So x plus x plus x, or 3x, 3 times x, plus 2 beans equals 3, 6, 8 beans. 3x plus 2 equals 8. Okay, that looks right. The first step in finding the value of x, well, we want to get x by itself on the left side of the equation. So I have two operations going on. I'm multiplying x times 3 and I'm adding 2. The first thing I would want to do is get rid of this additional 2, subtract 2 from both sides, or get rid of those 2 beans and take away 2 beans on the right side. So let's look at our answer choices. Add 2 beans to each side of the model. If I do that, I'm gonna make things, I'm just gonna more complicate it more. I'm gonna be adding beans here. That's not what we want to do. Subtract 2 beans from each side of the model. That's what we said. We want to get rid of 2 beans on each side of the model so that I just have 3x equals 6. So that's the answer choice. Let's look at the other ones just to make sure. Divide the beans equally among the 3 cups. Well, we would do that, but not first. That would be the second step. After we've subtracted 2, we would divide these into 3 groups of 2. Because I have 3 cups, that would be dividing by 3. And then we would see x equals 2, but that's not the first step. The first step would be to get rid of the extra 2. D says subtract 8 beans from each side of the model. We wouldn't be doing that because we're trying to isolate x on the left side. So the answer is answer choice B, subtract 2 beans from each side of the model. Problem 6, consider the model below. What equation is being represented by this model? Oh, we need to look at this key. Each one of these rectangles is x, so I have 3 x's on this side. The black square is -1, so I have -1 and -1. The white squares are 1. So I have on the left side 3 x's, 3x, and then this value would be -2, -2. 3x minus 2, or plus a -2, equals 3, 6, 9, 12, 13. Value of positive 13 on the right side. So the equation would be 3x minus 2 equals 13. What value of x would make this model true? Well, we need to solve for x, so let's do that here. 2 sides of my equation. I want to work on the left side to isolate x. First operation I'm going to undo is this -2. I can undo that -2 by adding 2 to both sides. -2 plus 2 is 0, so that goes away. So on the left side I just have 3x, and on the right side I have 13 plus 2, which is 15. So 3x equals 15. What I've really done is I've added 2 white squares on this side, which have a value of +1, and each of these pairs is a 0 pair, because -1, +1 is 0, so they go away. And of course, if I add 2 white squares on the left side, I have to add 2 white squares on the white side. And then we would have, instead of 13 squares, we'd have 15 squares. So we'd have 3x equals 15, which is what our equation shows. Now I'm multiplying x times 3. I can undo that multiplication with the inverse operation for multiplication, which is division. So divide both sides by 3. 3 divided by 3, that goes away, so we just have x on the right side, because 3 over 3 is 1. So x equals 15 divided by 3, which is 5. So x equals 5. We're going to check the value by plugging it back into our original equation. 3x minus 2 equals 13. If x equals 5, 3 times 5 minus 2 should equal 13. 3 times 5 is 15, and 15 minus 2 does equal 13, so that checks out. Make sure you show this work. If the problem on the test asks you to check it by plugging it back into the equation, make sure you do that. Okay, that does it for problem 6. We'll pick up the review with problem 7 on the next video.